So the question that I wanted to talk about is called 9 identical coins. The question is, there are 9 identical looking coins, one of them is a counterfeit, and it weighs less than the other coins. The only scale available is a balance scale, on which you can only weigh a number of coins. You can weigh any number of coins against each other. Using that scale only 2 times, figure out a way to find the counterfeit coin. So from this question, what we do know is that we're looking for a fake coin. There are 9 coins altogether. The fake coin is lighter than the others, and we can only use this scale 2 times to find the answer. So breaking it down, there are a couple of subproblems we're looking for within all of this as well. We need to know how heavy a normal coin is. How do we find the counterfeit only using the scale 2 times? And how can we be absolutely positive that the coin that we do pick is in fact the counterfeit? So to start off, step 1, you divide the 9 coins that you have up equally into sets of 3. So here I have Group A has 3 coins, Group B has 3 coins, and Group C has 3 coins. This is just to divvy it up so it makes it easier to manage. So step 2, you take 2 groups and you decide to weigh them. So in this example I have, I'm going to be measuring Group A versus Group B. And we'll place the third group, C, off to the side. So we have 3 on A and 3 on B. If Group A, so we're weighing Group A against Group B. It's the first time we're using this scale as well. So if the outcome of Group A is the exact same as Group B, so if it weighs the exact same, then we know for a fact that the counterfeit coin cannot be in these 2 groups because they weigh the same. If there was any difference in it, then we know there'd be a problem within that one. But because these 2 are equal, then we know that the coin that we're looking for is in the 3 of Group C. And we also know that this is how much 3 coins normally weigh. Because we know we're only looking for one single coin, and the only coin we're looking for is lighter than others. So if A and B are the same weight, then we need to look at Group 3. So we take Group A's 3 coins off and Group B's 3 coins off of both sides, because we know that they're completely fine. So to find the light coin from Group C, we only have one more chance to use the scale. We use 1 coin on both sides. So instead of using all 3, we're just taking one side of Group C and putting 1 coin, and then using the other side with the same group of Group C. If the 2 coins weigh the exact same, then the counterfeit coin is the one not being used from Group C, the one that we left off to the side. If 1 coin on the 2 is being measured as heavier than the other, so if the left side is going down, then we know that the right side has the lighter coin and is the counterfeit, because there's a discrepancy between those 2. So that's how we'd find it if A and B equaled the exact same amount of weight. But what if A and B were not the same? So if we measured Group A and Group B, and they came out with different weights, say Group A is heavier than Group B, then we know for a fact that Group B has the counterfeit coin because it is lighter than Group A, because A is heavier. So we do the exact same thing we did with the last one. We take 2 coins from Group B and weigh them against each other to find the weight. If 1 coin is heavier than the other on this scale, then the lighter side is going to be the one with the counterfeit. But if both coins weigh the exact same, then the coin that we took off from originally on Group B is going to be the counterfeit. So from this, we were able to divide our subproblems up and find the solution. We know how much a normal coin should be weighing, we know how to determine what coin is the counterfeit, and we know how to find this answer within 2 scale uses.